because we're going to do solving absolute value equations. So we first got to remember what an absolute value is, and there's probably 3 things that you can tell me. It can be what it looks like, what it does, or the actual definition. Cheyenne, what do you got?
The absolute value is like if you have a number in the bars, it turns into a positive number.
All right, so the first thing is what it looks like, and that's what it does also, right? That's the absolute value bars that she's talking about. Okay, and then she said anything inside becomes positive. So the absolute value of -3 is 3. The absolute value of 5 is 5. Always positive. Okay, that's what it looks like. That's what it does. So, right? All right, good. So what's the definition of it? That's the working part. Do you remember the definition?
Isn't it like however many places that number is from 0?
All right, good. Yeah, so it's the distance from 0. That's the actual definition. And that's why, because we're talking about a distance, and you're thinking of a number line usually is an easy way to think about it. That's why it's always positive, because you can't have a negative distance.
When do you normally put like 3, 2, 1, and 0, like, or 0, 1, 2, 3, and then that's your absolute value?
No, absolute value is just one number. It's just a distance, okay? I mean, you can plug in anything you want, but, okay?
Probably right now long.
All right, so that's what an absolute value is. All right, so step number 1 when you got an absolute value equation is to make sure every number and or variable is on the other side of the equation compared to the absolute value. Now the step I say up there is on the right side, because all the problems that we're going to look at, the absolute value starts on the left, so just leave it there and move every other number over first. You're making the problem much more simple, okay? So in this case, we're good. Everything's already taken care of there. Okay? So now we move down to the second step. And it says set up 2 equations. Okay, so all of these, you're going to have 2 equations that you're going to set up. Okay, so there's potentially 2 answers to every single one of these. Can we see all of that over there, or does it get cut off? Does it get cut off? Oh, man. Hold on. All right, so step number 1 again was make sure all numbers and variables that are outside of the absolute value are on the right-hand side. And again, it's just the opposite side. All of your all's problems, the absolute value will be on the left, so just leave that part alone, move everything else over. All right, this is a pretty basic one, and there's nothing for us to do on step 1. And again, step 2 says we split it into 2 equations, and this is what they should look like. The first one, bless you. The first equation, you just get rid of the absolute value. Okay, so 5x plus 1 equals 16. Okay, and then the second equation, you just drop the absolute value, so it's still 5x plus 1. And now you multiply everything on the right-hand side by -1. In this case, it's just 16. So now this is -16. Okay, so you've got 2 different equations going on. All right, now here's a really good question for you. Let's see if anyone can answer this. If I told you that an equation solution is actually the numbers you're allowed to plug in and make it satisfied, okay, if you keep that in mind, and you also know that the absolute value always makes the number positive no matter what it is, can someone explain why this step actually makes sense? What do you got?
Because you can have 2 answers, a positive and a negative.
Okay, and so that's exactly right. And so, this value here has to be positive 16. That's what this is saying here. Okay, so you say, well, this inside, there's a value for x that makes it positive 16. Plug in positive 16 here. Absolute value of positive 16 is positive 16. Or maybe this value gives me a negative 16, and that's also okay because the absolute value of negative 16 is also 16. Okay, so it's exactly what you said. That's big time. Does that make sense? That's why we're checking for two different things that could happen. Okay, we'll talk about that extraneous part here in a second. But now all you're doing is solving these two equations. So how do we solve the first equation here? Subtract 1. All right, and you get 5x equals 15. Divide by 5. X equals 3. All right, we're going to hold on to that for a second because then we're going to solve the next equation. All right, the nice thing is you're doing the same process. You're just going to get a different answer because you're starting with a different number. Okay, so we're still going to subtract 1. So we have 5x equals what now? Negative 17. Divide by 5. I'm trying to do this all on one screen. It's going to be tough. Jeez. Move it over here. All right, how are we doing? Is that okay? Gotta get used to your fractions. So now this is where this extraneous solution comes in. Does anyone know what extraneous solutions are? Has anyone even heard of that before? Okay.
It's a scary word.
It's a big word. We found out it's 4 syllables. That's a lot.
So 4 times.
Okay? Yeah. Especially in math. Okay? I don't know the exact word-for-word definition, but this is what it means. You solve the equation correctly, but that is still not a solution. That's extraneous. Okay? Everything is done correctly, but it doesn't work. Because again, the answer to an equation is what you plug in that does work. All right, so now we have to check. And you always want to check what you got after step 1, which in this case is this. Okay? This is after step 1. We didn't have to do anything. So now we're going to plug it in. Okay? So I'm going to try to do this, I guess, all at once here. So this is 5 times 3 plus 1 is the absolute value of that equals 16. Well, 5 times 3 is 15 plus 1. Absolute value of 16 does equal 16. So then, yes, 3 is definitely an answer. Okay? Always come back to an equation that has an absolute value. You just have to make sure that both sides are equal. You're not solving, you're just substituting in, simplifying, excuse me, both sides of the equation better give you the same thing.
Would you allow us to do it in our head if it's easy like that?
So you have to, if you have an extraneous solution, you have to show me that you know in some way
So you want us to do it?
that doesn't work. Well, you got to know. So, I mean, if you don't write it out, that's fine. But if you didn't check and it's not supposed to be an answer and you tell me it's an answer, then that's not correct. Okay? So you don't have to write out the steps. You know, you can punch all this in a calculator and check. Okay? And I can show you where that absolute value is on this calculator if you want. Okay? But you have to somehow signify, yes, I do understand that this is not a solution that works. Okay? All right, so we do have to check the other one, and it's going to be kind of tight down here. I'm going to try it anyway. So we have absolute value of 5 times negative 17 over 5 plus 1. Does that equal 16? And there's not much room.
Would it be negative 16?
No, don't do it there. Don't do it there. Always do it in an equation that has an absolute value, okay? What he's saying, he wanted to do it here. Don't do it there. This doesn't have an absolute value anymore. Because the process of solving absolute values is one of the steps is to get rid of them and set it equal to negative to find that other one. Always check into something that has an absolute value, okay? So now this is where you either know your fraction rules or you're using a calculator, right? 5 times negative 17 over 5 is negative 17. Okay, so negative 17 plus 1 is absolute value of 16. That does equal 16. So in this case, both of these are answers. Is that okay?
So that would be an answer we put down.
Yeah, so you might get, so you might have 2 answers, circle them both. If one of them doesn't work, say doesn't work, this one doesn't work, or exit out at least. Okay?
missed that.
Yeah, she's right. She's absolutely right. Yeah, sorry about that. This should be a negative right here.
Oh, okay.
Negative 16. But the absolute value of negative 16 is 16. Yeah, thank you. Yeah.
Good catch.
All right, is that okay? Keep your eyes on me. All right, well, I mean, no, never look at me. Never look at me. Don't look at me in the eyes. Right?
Scares them.
Stop it. No, sometimes I can't control the power. Okay? I always use it for good. The next one, and again, I'm always going to go through these steps. So the first step says make sure all numbers that are outside of the absolute value are on the other side, or in this case on the right-hand side. So do we have to worry about that step on this one?
Yes.
Yeah, we got that 3. Okay, so be careful. There's no addition sign with that, or subtraction sign. It's kind of shoved together. It's like 3 times. Okay, so we want to divide by 3. Does that make sense to everybody?
It's kind of like, it's like parentheses, basically.
Right? Because this is kind of like if this was like a parentheses instead of absolute value, you'd want to distribute, but we don't want to distribute inside. We need to get rid of this guy. We need to get it over here. Okay, this is 3 times the absolute value of all this. So the opposite of multiplication, division. So we're going to divide 18 by 3 here. Okay?
Which is 6.
So 6x, right? So the absolute value of 2x minus 5 equals 6x. Okay, now when we do our checking at the very end, we want to do it into this new equation because it's simpler. Okay, we simplified it a little bit. Now it'll be easier to check there. If you go back and check in the first one, you'll still be checking okay, but it's just a little bit more work. All right, step 1, okay?
Yeah.
All right, step 2 is what then? All right, so we got 2 equations. The first one is just get rid of the absolute value.
And then the other one's opposite.
Okay, so then what's the second equation look like then?
It'll be negative 6x instead.
All right, good. Nothing else changes except for the negative 6x in this problem, or the 6x becomes negative. Okay, that's the process. That's setting them up. Is that okay with everybody?
Yeah.
All right, here we go. So let's solve the first one. What are you going to do?
Divided by 2x.
Don't divide yet. If you want to, you good.
2x.
Minus 2x, yeah, subtract 2x from both sides. So then we got negative 5 equals 4x.
Oh, that's what you did there. And you divide by 4.
Divide by 4. I'll have to check on the next screen there. X, we're saying, we're thinking maybe x equals negative 5/4. Okay, we're not positive yet, but we've done it all correctly so far.
First step, let's do it 3 and divide by 4.
So yeah, what we did right here, right? We want this a simpler problem. We want the absolute value by itself, and this is 3 times this. Does that make sense? And so we're allowed to divide at any time by any number as long as we do every term, divide by every term. Divide every term by that number. So when we divide this side by 3, it basically just cancels that, and we have that. But then we had to come over here and divide this by 3, and so then we have 6x. Okay?
I get every part except the part where you're plugging in like with the fractions.
All right, well, so on the next screen, I'll write it out a little bit better for you, okay? Okay, but again, you guys can check this on the calculator. Do not get caught up with your fraction rules. Don't make that the problem with your answers, okay? All right, so let's solve the second equation. Same process, right? We're going to start off subtracting 2x. So now we have negative 5 equals what? Negative 8x. Now we're going to divide by negative 8. Negative divide by a negative.
Positive.
All right, so here's our 2 potential answers, right? That's the worst looking 6. Looks like a guy that has his knees bent backwards. Sitting.
He looks like a wobble man.
This is an 8.
That was a 6.
Let me get that better 8 for you guys.
Negative 5.
Well, we divided a negative 5 by a negative 8.
It's not that bad long. The teachers can't read my 2.
Is that right? And just like anything else, you're plugging it in every place. So we actually have to check it on both sides. Okay? So first step is, we'll do this one first. 2 times negative 5 over 4 minus 5. And we say, does that equal 6 times negative 5 over 4? I'm taking up too much room over here, but that's okay. All right, now your fraction rules say that that 2 is really 2 over 1. Okay, and you multiply straight across. And so then you're saying, then that first step is actually the absolute value of negative 10 over 4 minus 5. And likewise on the other side here, that's really 6 over 1. So when we multiply straight across, we get negative 30 over 4. Okay? All right. All right, now, again, you could reduce these, but we just need to check. So I'm going to not reduce them right now, and I'm going to say that minus 5 with a common denominator of 4 is negative 20 over 4. Does that make sense? Okay, so this is really negative 20 over 4. Well, I don't have enough room. This is really negative 20 over 4. So negative 10, right, when you're adding or subtracting fractions, leave the denominator, once the denominators are the same, leave them alone, go straight across.
I know I said I got it, but why was that being negative 20?
Because you got a common denominator, and this is 5 over 1. Multiply top and bottom by 4. 5 times 4 is 20. 1 times 4 is 4. Okay? So then now we have the absolute value of negative 30 over 4 equals negative 30 over 4. And again, don't get caught up on your fraction rules, right? If you get caught up on stuff like that, then these problems become more immense and very difficult because you got to really, think hard every step of the way. But this is a true statement.
I'm kind of lost.
On what?
I got everything, but I don't get why did Dad do that the 12.
What's that?
It's not
That's absolute value.
absolute value.
That's absolute value.
I'm really confused on the negative.
We're just checking to see if this is
You're
actually.
just plugging it back in.
Yep.
Okay.
How do we get negative 30 over 4?
Hmm?
How do we get negative 30 over 4?
So is that a true statement?
Well, doesn't the negative 30 over 4 have to become positive? So it's absolute.
All right, so no, this is not because this is still inside the absolute value. There's another operation still, which is the absolute value, always makes it positive. So this is really saying positive 30 over 4 equals negative 30 over 4. So no, this one doesn't work. And so here you go. You can just do this. No, that doesn't work.
So you just cross.
That's an extraneous. Yeah, if you cross it out, I know that it doesn't work. That's extraneous. Okay? So really, if you think about it, right, Tori? Right, if you think about it, if you plug in the number over on the right-hand side and you get a negative value, you don't even have to go anywhere, right? You can stop right there because there's no way an absolute value on this side is going to be negative. Okay, so we knew right here. We didn't even have to check. We knew right there. No way it's going to work. It can't be negative. That's absolute values can't be negative. Okay? But we do have to check on the other side. So let's check this one too. Okay? All right, so now absolute value of 2 times 5 over 8 minus 5. Does that equal 6 times 5 over 8? It's going to look sloppy. There we go. All right, again, I'm just going straight across. Absolute value, that's absolute value. Sorry, it looks like a 12. Absolute value of 10 over 8. Right? 5 becomes 40 over 8. Does that equal 6 times 5 is 30 over 8? Okay, for the same reason. This says the absolute value of negative 30 over 8. Does that equal 30 over 8? Yes, it does, right? Because it makes it positive on the left-hand side. So this is an answer. That's our only answer, 5 over 8.
Are they always going to become fractions like that?
No, I mean some of them. You'll have to deal with fractions. You got to deal with fractions this year. Right?
Sucker handy.
Again, if you got trouble with fractions, I understand, but don't let that be the problem in this class, okay? All right, so going through those steps again. Excuse me. First step always should be to make sure that all numbers and variables that are outside of the absolute value are on the other side of the equation. Is that true in this case?
Yes.
All right, great. So we can move on to number 2. Okay, that says set up your 2 equations. So what is our first equation going to look like?
4x plus 1 equals 2x plus 5.
Right, nice and easy. Okay, and there's a reason we're doing this problem. Because the second equation says drop the absolute value, so it's still going to be 4x plus 1. But then it says multiply that whole other side by negative 1.
So that all turns negative.
So yeah, everything changes, right? Minus 2x,
We can write it out then.
minus 5. Okay, so really what you're doing,
Yeah.
right, is saying, right, it's 4x plus 1 equals negative 1 times 2x plus 5.
Does that make sense?
That's why all the signs change, okay? Because you got to multiply by, everything over there needs multiplied by negative 1. If you use your parentheses, maybe that'll help you remember that you're distributing there. Is that all right? That's the thing you got to worry about. Now it's just the same. Everything's the same. So it's just solve the first equation. How do you want to do that?
Basically, what you gotta do is you gotta add 1
You better not add it.
or subtract.
All right, so subtract 1. So we got 4x equals 2x plus 4.
And then you divide it.
Not yet. I'd get your x's together first.
Sorry, then you subtract 2x on both sides.
All right, so then you got 2x equals 4.
And then that's when you divide 2.
So now that makes it easier to divide now. So x equals 2. That might be an answer. We'll have to check here in a second. Is that okay?
You said the other way up.
All right, so now same thing. We'll start off the same way for the second one. Subtract 1. 4x equals, negative 2x minus 6. Now we're adding 2x. 6x equals 6. Divide by 6. Another answer could be x equals 1.
Negative 1, right?
Is there a negative 1? Did I mess up? Did I drop? Yeah, I dropped my sign. Thank you. Thank you. Don't do that. Don't drop your signs.
I dropped it. You can drop the mic,
Right?
but not the sign.
No.
Gotta tell you about these fresh. The fresh speaks about math.
Oh, man. You got those copied down. Remember, you are always checking into an equation with the absolute value sign. Okay, otherwise you're not going to get the right information. Right, we're going to check these two. Every place you see an x, you better put it in. So the absolute value of 4 times 2 plus 1, does that equal 2 times 2 plus 5? All right, well, this left-hand side, 4 times 2 is what? 8 plus 1? 9. Does the absolute value of 9 equal what's 2 times 2? Plus 5? Does the absolute value of 9 equal 9? All right, that's an answer. All right, let's check over here. Absolute value of 4 times negative 1 plus 1. Does that equal 2? Equal 2 times negative 1 plus 5. Right, so what's 4 times negative 1? Negative 4 plus 1. All right, so then that's the absolute value of negative 3. Does that equal 2 times negative 1 is plus 5? So does the absolute value of negative 3 equal 3?
Yep.
All right, we got our 2 answers. No extraneous solutions. You got to tell me somehow that you know they're both answers or that one of them doesn't work or whatever.